Continues with our next learning target of simplifying by combining like terms and multiplying. Okay, so first thing we notice here on number 1 is that we definitely have to distribute. So this is going to distribute through. So this is something we're just refreshing your abilities to be able to distribute and combine like terms. So this would be negative 3x cubed. When you have the squared in the first, you make it the cube, and then distribute the negative through. So plus 6x squared y. And we do not distribute to the 9x cubed, so we also have a 9x cubed. Okay, so negative 3x cubed and 9x cubed makes 6x to the third power plus 6x squared y. It's just a refresher on simplifying. Okay, and this one here, this is going to be a big one that comes up a lot this year. You have to think about this as any number squared is that number times itself. So you could actually rewrite this by getting rid of the squared and writing x plus 5y next to it. So that's called a binomial squared, and we're going to expand this. So when you FOIL this, that would be x squared for the first. Outside is going to give you 5xy. Inside is also going to give you 5xy, and then the last will give you a positive 25y squared. I'm going to change this a little bit bigger there. There we go. So we're actually going to have x squared plus 10xy plus 25y squared. Probably pretty confident in your foiling skills. Just recognize that this is a binomial squared, a foiling problem. Okay, be careful here. We're to the third power. So what I'm actually going to do in my head right now is I'm actually going to take this as if it said squared. Okay, so I'm going to say to you what we just said is that if we were to expand this out, binomial expansion, that would be 9x squared. Outside and inside would both be negative 6x. So we're going to have a minus 12x and then plus 4. So what I just did is I took this as if it said squared, and I did what we just did on number 2. 3x minus 2 times 3x minus 2 is that. But the problem is that's only 2 of them. So I still have 3x minus 2 on the outside. Okay, so now what we're going to do is we're going to actually distribute the 3x back to each part. Okay, so that's how we're going to take this next part. So 9 times 3x is actually 27x to the third power. And then we have minus 12 times 3, so we're going to have 36x squared, and then plus 12x. And I'll never be able to write all this in the same line, so I'm going to take the negative 2 here and do the same thing, distribute it all 3 parts. So that's going to give me negative 18x squared, then a positive 24x, and then a negative 8. And then I'll go back to black here and we'll rewrite the whole problem. Combining like terms, we'll have 27x cubed, negative 36, and negative 18 is a negative 54x squared. So those are taken care of there. And then we have 36x's, so positive 36x's, and then minus 8. So there would be our final answer to that problem. Okay, now we're jumping and saying let's factor. Okay, so the first thing we always do when we factor is you always want to try to look for a GCF. So looking here, since they're both even numbers, I definitely see that a 2 is going to come out. Okay, and that's the largest number that comes out. I'm going to take an x out as well. And I can also take a y out. So that's going to leave me with 2 times something that gives me 16. So that's going to be 8. We are missing an x squared with the variables. And then minus, well, it looks like 2xy. We're only missing the y's, and we're missing 3 of them. So y cubed. And then this is not a difference of squares, not a difference of perfect cubes. So we know actually we can't go any further with that problem. This is the good old difference of perfect squares. There is no GCF, so as a refresher to you, this is how we factor a difference of perfect squares. We take the square root of the first part, put it in the front 2 slots, square root of the second part, put it in the back 2 slots, plus and a minus. And if you FOIL that out real quick, you'll see the outside and insides, they cancel off, and you do get the difference of squares there. All right, and then this one here, no GCF, 2, 7, and 15 has no number that goes in. But what I like to do is I like to get my signs going right away. So I see that there's a minus. If there's ever a minus right there, there's always going to be a minus and a plus in the problem, because the last terms have to multiply to give you a negative. So we'll just try. It would make sense, since the only factors of 2 are 2 and 1, that we're going to have like a 2x and an x. All right, and then factors of 15, well, you obviously can play around and be like, all right, I'm going to try 5 and 3. That's why it's called guess and check. But if you look here, the outside and the inside actually give me a positive 7x, and I don't want a positive 7x. So what we want to do whenever that happens is, well, make it a negative 7x by taking and getting rid of our signs and switching them, okay? So actually what we wanted to have here was a negative 5 here and a positive 3 there. Whoops, sorry. That's not, let me get that off. So that was a positive 3. So this is actually the correct factoring of that problem. And this now creates a negative when we FOIL it. Okay, look in here. Don't forget, you think you're getting the hang of it, but like, okay, wait a minute, what am I supposed to do? GCF. The 7 comes out, and actually the largest amount of x's we can take out is a cube. So that's going to be 7x cubed onto x squared minus 1. And then this is a difference of perfect squares. So we're going to go 7x cubed, and then make sure we break down the difference of perfect squares like mentioned on number 2 there, x plus 1, x minus 1. Okay, now this is one you'll probably most need refreshing. Some of you might have even fast forwarded the video to this point. This is what I refer to as a DOC, a difference of cubes. So what I say on this one, just to kind of remember it and have a little fun with it, is to SDAP that signage, yo. So here we go. We're going to SDAP that signage. We have a binomial, and then we have a trinomial. That's always going to happen with a difference of cubes, okay? So we can't have a difference of opinion on that. All right, so difference of cubes, SDAP. So we're going to take our blue here. The sign is negative, so we want to go same, different, always positive. So we want to keep it the same. Then we want to go different, and then we want to go always positive. Okay? So then we look at the x cubed. Cube root of x cubed is x, so we put an x in the front, and then we say, what's x times x? That's x squared. That goes in the front one there. And then the cube root of 8 is 2. What's 2 times 2? 4. And then finally, how do we get that last term? We look at these two, and we just multiply them together, and we get 2x. And that's totally the final answer. So if you were to distribute the x through and then the negative 2 through, kind of like what we did up here on this problem, you would see that this is going to have a lot of things cancel out, and you'll get back to x cubed minus 8, which would verify that we're correct. Okay, so just another one of those right here. No GCF, another DOC. This is a difference of perfect cubes again. So we have this problem, and we're like, okay, same, different, always positive. And then the 27x cubed, oh, cube root is 3x. So this becomes a 9x squared, because you need to square that entire part, or times it by itself. Cube root of 125 is actually 5. So we have a 25 on the back end. And then the product of 3x and 5 is 15x. And remember, don't worry about the sign, because you already took care of the signs a minute ago. Okay, cruising along, here we go. We'll get another learning target in here. Now we're solving. So now the game changes. Now we got an equation, and we're going to have to get down to a final answer. So again, just like before, we're going to distribute, but we have an equation to work with here. So 8x minus 12 minus 2 equals 10. Sorry about my 2's. I do this. I make them different. I don't know why. I don't know why. So 8x minus 14 is actually equal to 10. 8x is going to end up being equal to 24 when we add 14 to both sides. Divide by 8, we're getting ourselves our 3. So x is 3, we would plug it in and check it. Always want to do that. Works out great. Next one, something funky is going to happen here. We're going to have 6x minus 2 equal to 6x minus 2 when you distribute through. Well, when you look at this, you say, well, this is the same thing as that. Basically what that means is no matter what real number you put in for x, this is going to work out. I mean, think about this. Let me show you it a little bit simpler. If I add 2 to both sides, okay, when I add 2 to both sides, I have 6x equal to 6x. when you plug something in to see if it works, if I plug in 5, 30 would equal 30. If I plug in 1, 6 would equal 6. If I plug in a fraction, that would equal the other side. So what it means is there's actually an infinite number of solutions here when you think about it. It's not infinity for the answer, but there is an infinite number of solutions. Any real number. Another way to put that is any real number. The symbol like any real number would work in that equation. Okay, moving along, let me drag this down. Rationals. Now these are the ones that throw kids for loops, but make them easy. If you hate these fractions here, get rid of them. The common denominator between 4 and 1 here is 4. So I'm literally going to multiply this side by 4 and that side by 4. You could also cross multiply, or there's different ways to do these, but the 4s will basically just cancel on that side. So in the second step of an ugly fraction problem, you should have no fraction. Okay? So we're going to have 2x equals 1. We subtract 7 from both sides, and x is going to equal 1/2. Okay, so looking at this problem number 2 here, I'll give you a second. Think about the common denominator. Okay, did you get 12? Well, if you got 12, then it's okay. I'm not going to try to get 12. I'm going to try to completely get rid of fractions. So I want you to see this. I'm going to take this and I'm going to multiply this first one by 12 over 1. The second one here, it's hard to show, but 12 over 1. This 2 right in there times 12 over 1. And then this here times 12 over 1. So in the first part here, switch colors so we can see this, the 12 and the 3 are going to reduce to 4 over 1. All right, so then we have 8x. That's all we have left there is 8x, no fractions. And the second one here, the 12s cancel, so all you have left is literally the number 1. 2 times 12 is going to give you 24. And then we're going to add, 12 over 4 is 3 over 1, so we have 15x. So look at that. Nobody would freak out about that problem, but you do about that one. So multiply by the LCD. So multiply by LCD to all parts, and you'll get rid of those fractions. All right, I'm going to bring those x's over here, and I'm actually going to make that a 7x. And I'm going to bring those over here, and I'm going to make it a negative 23. So I'm not too worried about you getting this part right. I think you'll be fine. So negative 23 over 7. Okay, moving along, we have here radicals. So radicals, the steps are, hopefully you're hearing them, is to isolate the radical, get it by itself, and then you want to square or cube both sides if you need to. So the first thing I'm going to do here is not add those two together. There's a multiplication here that you can't mess with. So we're going to subtract 3. So 2 times x plus root 5, the square root of x plus 5 is equal to 10 when you minus 3 from both sides. Next thing I do is divide by 2, and I have the square root of x plus 5 equal to 5. All right, and then I'm going to square both sides. So now I'll have x plus 5 on the left. Think about it. A radical times a radical is itself, right? So a radical times a radical is just the radicand. So it's just x plus 5. I mean, if you're not getting what I'm saying here, what is the square root of 5 times the square root of 5? Well, that's really the square root of 25, right? Well, what's the square root of 25? Just 5. So if we have root x plus 5 times root x plus 5, which is what the same as squaring it is, we're just going to get x plus 5 out. So then we get all the way down here, and we see that x is supposed to be 20. If you plug it back in, you always want to plug back in to check. Some of these don't work out. 20 plus 5 is 25, right? Well, the square root of 25 is 5. 2 times 5 is 10, plus 3, 13, and that makes you go, woohoo! All right, moving along. On the next one, I'm going to tell you right now that the answer is no solution, and I'm done. Because I can't take the radical of a number. I can take the square root of a number, I guess I should say. I can't take the square root of a number and get a negative. All right, square root of any number we know is going to be a positive number. It's called the principal square root. But if we look at this, if you weren't thinking that and just going through the motions of, square both sides, I just want you to think about this. Okay, you would actually get x minus 3 equals, negative 10 squared is 100. That's what you would get. And then you would get an answer of x equals 103, and you'd think that you have an answer. Well, this is an extraneous solution. It's a solution that we created by solving the problem. And it doesn't work. When you plug it in, you'll see that the square root of 100 is not equal to -10. So this is not good, and actually no solution exists for that problem in the real number system. All right, so again, we're going to take the cube root of x minus 2 here, but I'm going to set it equal to 4 because we want to subtract 8 from both sides. And then now, to take the cube root of something, we're actually going to cube it. And if we cube both sides, it makes sense that we would have just x minus 2 based on the conversation we had up here earlier. If you put another one in there, it's just going to be x minus 2 when you cube it. Okay, so 4 cubed, 4 times 4 is 16, times 4 is 64. So we actually get, when we add 2 to both sides, x equals 66. And if you plug it in, 66 minus 2 is 64. Cube root of 64 is 4, plus 8 is 12, and it also makes you happy. Okay, moving to the last page here. All right, last page. Absolute value. Video's actually getting a little long. I'm going to cut it off here, and I'll come back for a second one.